At the end of the last 4G spectrum allocation process, O2 ended up relatively light in spectrum compared to their competitors, especially when customer number is taken into account. However, O2 has managed their limited 4G spectrum allocations very successfully, partly due to additional capacity strategies like highly sectorized masts as well as microcell deployments, but also just due to the fact that O2's customers historically have not been very high mobile data users. Fortunately, there will be imminently spectrum auctions for the 2.3 GHz band and the 3.4 GHz band. Now, the 2.3 GHz band is the frequency that everyone wants because it's readily supported by current devices. So say iPhone supports 2.3 GHz no problem, as do many other flagship and modern devices. However, the 2.3 GHz band has only 40 MHz of spectrum available in 4 10 MHz lots, and because of its ready usability, relatively low frequency, especially compared to the 3.4 GHz, it is a very, very wanted piece of spectrum. A very wanted piece of spectrum that O2 has been seen radiating from a site near their headquarters in Slough. Now, this site was broadcasting the 2.3 GHz TDD spectrum with a 20 MHz carrier, and it was using the mobile network code of O2. O2's normal public network broadcasting code is 10, so 23410 to give its full number. However, this spectrum was broadcasting on 23402, which is O2's test network code. And as you can see from the screenshot, it is a 20 MHz carrier, which would indicate O2 buying two 10 MHz allocation pieces, which is pretty much to be expected. Probably the most likely scenario is O2 gets 20 MHz and 3 get 20 MHz, but you'll have to wait until the conclusion of that spectrum auction to find out the end results. The 2.3 GHz that the mast is radiating is not the only really interesting part of this deployment. The mast itself is actually very interesting in a number of different ways. Now, I've drawn a schematic for it to try and make things a little bit simpler. However, it has quite a number of different antennas on it in quite a number of different stacks. So the top of the mast has 3 triple band Comscope Argus panels, of which the low band port and one set of the high band port are connected up. The high band ports go to an RIU, so will be for 2100 MHz, and the low band ones go to the ground based BTS. As this is in an O2 hosted area, the LTE will be done by O2, and therefore those feeders are most likely solely for Vodafone's 900 MHz 2G, 3G. However, the fun really starts once you enter the stack below that one, which has 3 antennas on it, which vary massively in terms of number of ports and age. So on the left here we have a triple band Catherine antenna, which is a fairly legacy one, of which 2 out of its 3 bands are connected. And these are connected via a diplexer, and from the tags you can appreciate that 2 of the feeders to the antenna carry 900 MHz 2G, so G09, and 2 of them are carrying G18, which is then diplexed into 2 feeders to the BTS, and then the BTS then diplexed out again to the 4 feeders for the G09 and G18. Now, the G18 is likely decommissioned on this site because it's a sort of modernised, beaconised site, as we'll find out shortly. This triple band legacy Catherine panel has spare ports on it, which would have been for the 3G 2100 MHz. Now this 3G 2100 MHz now has been rerouted and is fed into a diplexer with L18 into the new triple band Comscope Argus, which is in the middle. The Comscope Argus panel also gets LO8 and UO9, which are themselves diplexed into the antenna, and also a further U21, which is presumably a modernised U21 feed based on the new MHA for this 2100 feed from the ground. The panel on the right is the most interesting one. It has 9 feeder ports on it, which is very, very strange, and all 9 of them go to a Huawei ROU, which itself is rather strange when you think about it. This 9-port Huawei antenna connecting to the Huawei ROU, the feeder tags have T23 or L23 written on them, and certainly L23 indicates L23, i.e. 4G 2300 MHz, or this 2.3 GHz we've seen in the screenshot before. However, the sheer number of feeders going to the ROU indicates something along the lines of an 8T8R deployment, which is high level MIMO, and also potentially looking at things like beamforming, which would massively increase the range and capacity of a 2.3 GHz site, which are both things that are very, very definitely appreciated. However, this is odd, namely because of the Huawei ROU, because O2 has recently signed a deal with Nokia and also uses Ericsson in their controlled areas. So up until this point, O2 uses Nokia Siemens Networks or NSN, and Ericsson, whereas Vodafone areas use Huawei, NSN and Ericsson. So you don't really see O2 doing Huawei, so that's quite interesting. However, Huawei has a large presence in markets which actually already have auctioned off 2.3 GHz and have it in active deployment. So maybe their intended vendors that they'll use for their actual deployment of this, if should they win the spectrum, were not ready with the equipment in order to do the trial at this time. It is also possible to tell that this mast has gained TDD broadcast through the presence of a GPS antenna appearing at the top of it. And timing through GPS is very important for TDD because it is a time-based scheme, unlike FDD, which is frequency-based. So the GPS antenna is basically a surefire way of telling that a mast is likely to be getting a TDD-based system in the cellular world, albeit some masts do get GPS antennas for other reasons. Thank you for watching this. It's been quite an interesting day visiting this site and being able to check it out and see the things that it's radiating, as well as the nice and sophisticated antenna array on it, and I hope you've enjoyed it as much as I have.